All right, guys, hopefully these notes today will be short and sweet because this is something that you should have covered in middle school. This shouldn't be the first time you are seeing this. So they should be short, sweet, and to the point, hopefully. I'll do my best to keep them that way. So speed is the amount of distance covered per unit of time. So the distance covered per unit of time. Another way to put speed is it's how fast something is moving. That's kind of the layman's definition, right? And I want to know how fast something is. I'm going to underline this in red, maybe draw some arrows. So I know I'm like being left in the dust. When we talk about speed, direction doesn't matter. So that means if it doesn't have direction, that speed is a scalar quantity. It can't be a vector quantity because we don't know the direction. It doesn't matter. So the speed equation, at some point you were probably taught that you put an S here. We're going to put a V here because after these notes, we're going to take notes on something called velocity. And the velocity equation is going to be really close to the speed equation. And we're going to define velocity. So we're going to go ahead and leave this here as this V. So we're going to have speed. This V represents speed up here. And the units we're going to use for speed are going to be meters per second or kilometers per hour. If our units aren't given to us in the problem in meters per second or kilometers per hour, we're going to need to convert them into something. And we're going to need to convert them into either meters per second or kilometers per hour. So that's when all of that dimensional analysis and unit conversion we practiced comes into place. This T down here represents time. Time units are seconds or hours. And this D at the very top is going to represent our distance. And our distance is going to be given to us in meters or kilometers. You can tell that if we have meters or kilometers on top, we have seconds or hours on bottom. That's how we're getting these meters per second or kilometers per hour measurements. And a lot of times to make life easier, we use something called a speed triangle to solve these. So a speed triangle is a massive triangle that you draw with a division in the middle. You put your V down here in the bottom. So speed is equal to distance over time. Now, as we're solving, all we have to do is cover up the one we're looking for. So if we're looking for speed, we'll cover up the V, and it's equal to distance divided by time. If we're looking for distance, we'll cover up the D, and distance is equal to velocity times time. If we're looking for time, we cover up the T, and time is equal to distance divided by speed or velocity. So let's apply this to some problems and see how well we do. A skateboarder can travel 350 miles in 52 seconds. What is the skateboarder's speed? So I always like to start off with what I am given. So I'm going to put my V here. I'm going to put my D here and my T. And in the very last sentence says, what is the skateboarder's speed? So this V, this velocity, that's what we're looking for. That's our question mark. It says the skateboarder can travel 350 meters. So that's my distance. I'm going to put that next to D. And it says that skateboarder has a time of 52 seconds. So now I need to figure out what equation I'm going to use and plug it in. So since I'm looking for V, I'm going to cover up the V. So my velocity is equal to distance over time. So my velocity is equal to, let's plug in what I have. My distance is 350 meters. Oh, that one's not open. Divided by my time of 52 seconds. When I plug that into my calculator, I get my velocity of 6.73 meters per second. When I take significant digits into account, I have 2 here and I have 3 here. So I'm going to report my answer with 2 sig figs. So the skateboarder's speed is 6.7 meters per second. And that is going to be my final answer for that one. Let's try a next one. A motorbike travels at 42 kilometers per hour for 28 minutes. How far did the motorbike travel? All right, so let's write down what we need to find here. Velocity, distance, time. All right, our velocity is 42 kilometers per hour. Right off the bat, it told us that. For 28 minutes. So that must mean our time is 28 minutes. How far did the motorbike travel? So we're going to be looking for distance in this problem. But before we can get started, we've got a problem. Our velocity was given to us in kilometers per hour, and our time was given to us in minutes. Our units have to match before we can work through the problem. So we need to convert these minutes into hours. So if I have 28 minutes, and in every 60 minutes, I have 1 hour. My minutes cancel, and I get 0.46 hours. All right, so now let's go back up here and let's decide what we need. We know velocity, we know time, we're looking for distance, so I'm going to cover up the D. So distance is equal to velocity times time. All right, so let's plug in what we know. Our distance is equal to, our velocity was 42 kilometers per hour. And I'm going to write it just a little bit different to help y'all out some here. I'm going to put 42 kilometers over hour. Times our time was 0.46 hours. Our units cancel. 42 times 0.46. Our distance is 19.6 kilometers. When we look at sig figs, we can only have 2. So my final answer is going to be the bike travels about, let them know that number was rounded, 20 kilometers. All right, last but not least, we've got an ambulance. And it needs to travel 8.2 kilometers to the hospital. It can maintain a speed of 75 kilometers per hour. How long does it take in minutes to get to the hospital? So let's start with what we know we need to know. We know we need velocity, distance, and time. All right, so it says an ambulance needs to travel 8.2 kilometers to the hospital. So our distance is 8.2 kilometers. If it can maintain a speed, oh, that was easy. It gave it to us in the exact same word, of 75 kilometers per hour. How long does it take in minutes? That's important to get to the hospital. So we're looking for time. We're going to cover up the t. So time is equal to distance divided by velocity or speed. So I'm going to write out the formula I'm going to use. So time is equal to distance over velocity. So I'm going to plug it in. Time is equal to, my distance is 8.2 kilometers. My velocity is 75 kilometers over hour. My units cancel. My time is approximately 0.1093 hours. Great. We've got an answer. But we don't, because it says minutes here and I have an answer in hours. So this doesn't answer the problem. I need to convert these hours into minutes in order to answer the problem. So I know in 1 hour, there's 60 minutes. My hours cancel. My math gives me that my time is about 5 point, that's wrong, 6.56 minutes, which is pretty fast if you ask me. But I'm still not done yet, because when I look at my math up here, we have 2 sig figs and 2 sig figs, and this is 3 sig figs. So let's write a sentence and answer the problem. So my sentence is going to say, the ambulance takes 6.6 minutes to get to the hospital. So now I'm done with this problem. If you have any questions about speed, please let me know, or you need any help with this worksheet.